Hi everyone! In this video, we are going to learn about Lewis structure, focusing on how to draw a Lewis structure. Let us go through the learning outcomes for this video. 4.1 Lewis structure. D. Draw Lewis structure of covalent species with single, double and triple bonds. E. Compare the bond length between single, double and triple bonds. Now, what is a Lewis structure? Lewis structure is a way of representing a molecule by showing all the elements, types of bondings and arrangement of electrons. As we can see here, this is a Lewis structure of water, H2O. Oxygen being the central atom and two hydrogen atoms as the terminal atoms bonded in two single bonds represented by straight lines. These two pairs of electrons are called lone pairs. You will be learning more about lone pairs in future lessons. So, how to draw a Lewis structure? Step 1. Count total valence electrons. Step 2. Place the more electropositive atom as the central atom. Step 3. Make sure terminal atoms are octet. And step 4. Place the remaining valence electrons on the central atom as lone pair. Let's do some hands-on activity, shall we? Using methane as our first example. Methane is a covalent species with only single bonds. First, we calculate the total number of valence electrons in methane. One carbon atom has 4 valence electrons, whereas 4 hydrogen atoms with 1 valence electrons each add up to 4 valence electrons. Therefore, we have 8 valence electrons in total. That was our first step. Next, place the carbon atom as the central atom. This was the second step. Then, draw 4 lines representing the covalent bond around the central atom carbon to occupy all 4 hydrogen atoms. Here, we have to subtract all 8 electrons used in all 4 covalent bonds, since each covalent bond consists of 2 shared electrons. Please keep in mind, hydrogen atom as terminal atom has to be in duplet configuration only, and there is no remaining electrons. Therefore, we can skip step 3 and step 4. There we have it, the Lewis structure of methane. Easy, isn't it? Moving into the next example, carbon dioxide, CO2. Carbon dioxide is a covalent species with double bonds. First, calculate the total number of valence electrons in carbon dioxide. One carbon atom has 4 valence electrons, whereas 2 oxygen atoms with 6 valence electrons each add up to 12 valence electrons. Therefore, we have 16 valence electrons in total. That was the first step. Next, place the carbon atom as the central atom. This was the second step. Then, draw 2 lines representing the covalent bonds to either side of the carbon atom to occupy both oxygen atoms. Here, we must subtract 4 electrons from the total number of valence electrons, since each covalent bond consists of 2 shared electrons. Step 3. Fill in the pair of electrons on both oxygen atoms so that they both have octet configuration. Here, we must subtract these 12 electrons from the total number of valence electrons. As we can see here, there is no remaining electrons. Therefore, we can skip step 4. But we are not finished yet. Please keep in mind carbon, oxygen and nitrogen as the central atom must be in octet configuration. As we can see here, the carbon atom has only 4 electrons surrounding it. Therefore, we have to convert the electron pairs from the terminal atom into covalent bond until the central atom achieves octet configuration. There we have it, the Lewis structure of carbon dioxide. The last example is carbon monoxide, CO. CO is a covalent species with triple bond. As usual, calculate the total number of valence electrons in carbon monoxide. One carbon atom has 4 valence electrons, whereas one oxygen atom has 6 valence electrons. Therefore, we have 10 valence electrons in total. That was the first step. Next, place the carbon atom as the central atom. This was the second step. Then, draw a line representing the covalent bond to occupy the oxygen atom. Here, we subtract 2 electrons from the total number of valence electrons, since each covalent bond consists of 2 shared electrons. Step 3. Fill in the pair of electrons on the oxygen atom so that it can achieve octet configuration. Here, we must subtract these 6 electrons from the total valence electrons. There are 2 remaining electrons. Therefore, we proceed to step 4. Place the remaining electrons as a lone pair on the carbon atom. Please remember, carbon is chosen as the central atom because carbon is more electropositive than oxygen atom. But we are not finished yet. Please keep in mind, carbon, oxygen and nitrogen as the central atom must be in octet configuration. As we can see here, the carbon atom has only 4 electrons surrounding it. Therefore, we have to convert the electron pairs from the terminal atom into the covalent bond until the central atom achieves octet configuration. There we have it, the Lewis structure of carbon monoxide. Now, let's focus on the second learning outcomes for this video, comparing the bond length between single, double and triple bonds. In terms of distance between the nuclei of 2 covalent bonded atoms in a molecule, we can see that triple bond has the shortest bond length. And in terms of energy required to break the bond, triple bond has the highest bond energy. Therefore, we can conclude that shorter the bond, stronger the bond. Please remember, covalent bond and dative bond cannot be differentiated from their bond length. Well, that's it for this video. Please proceed to the next video to learn more on exception to octet rule. Thank you.